This is Sydney speaking, and I'll be running this webinar. This will be, by the way, we'll be starting these webinars on a weekly basis, except for next week. We won't have one next week. After that, we'll be having it on a weekly basis. The subject of this particular webinar is thread mill and drill recognition. We are going to be dealing with those two options in SolidCAM. Now, before I continue, let me just remind everyone that if you have a question, all you have to do is click on raise hand, write your question inside the question area, and when you finish writing the question, just click on send right underneath that. And at the end of the webinar, I'll go through the questions and try to answer the questions as best as I can. Okay, so as I said, the subject of this webinar is thread mill and drill recognition. Now, I'm going to first actually start with drill recognition, and I'm going to do it on the part that I have here on my screen. Now, let me just take away the stock material and the fixture so it'll be a little easier to see the part itself. And first, with drill recognition, what I'd like to do is drill out all of these holes as shown over here. Now, you should note that these holes that you see over here, they're on different heights, on different steps. Not all of them are the same diameter. They have different diameters. I can also tell you, if we take a look using this view over here, you can see also that the depth of each hole, even though these two holes may be the same diameter, but if we take a look at the side of it, let me just put it this way, you can see it a little better. You can see that they go to different depths as well. So we'll be dealing with that. We'll show you how to do that in drill recognition on those parts itself. Okay, let me just put this back the way I like to look at it. Okay, now let's take a quick look at our stock itself. And if we right click on the stock, just a moment, right click on the stock, do show stock. This is my actual stock part over here, as shown over here. That's my stock, and that's my target, as you see over there. Okay, now obviously before I actually start machining the part, we start the drill recognition and the thread mill, I have to get rid of that excess material that we have over there, all the material over there. So obviously the most obvious way to get rid of that material and the quickest way and the most efficient way is by using eye machining, which I've done over here, as this is the most efficient way to get rid of the material. Let me just do a quick simulation to show you exactly what I did over there. And as you can see, it's doing the eye machining toolpath on the first area. Let me slow it down just a touch. Creating this area, then working in a morph spiral in this area over here, then cleaning out this hole. The steps. Basically, we're ready now for my drill recognition as shown over here. I have all my material milled out, and we're going to start with the drill recognition. Okay. Now, what exactly is drill recognition? Drill recognition, first of all, is a tool, is a one tool operation. It's creating an operation to work with one specific tool. However, the drill recognition, what it does, it recognizes the actual way the hole itself is built, as far as how deep each hole is, at what level it starts, the diameter of each hole. All this is recognized in the drill recognition, and we'll take a look exactly how this works. Now, because it does all that, it allows me in many cases to pick a series of holes to be drilled out in one operation, such as these holes over here, which are the same diameter, so I can use the same tool for all three of these holes. And before I would have to do separate operations for this, a separate one for this, because it's a different depth. This one is a different upper level, and this one's also a different upper level. So I'm going to have 4 different operations just to drill out these holes over here, whereas now I can do it all in one operation. Let's take a look at how this works, and I'll go into the option of recognition, drill recognition. Now, let's go into choosing my geometry. When I choose my geometry, I have a dialog window that opens up on the left-hand side of the screen, and with several different types of filters. I can filter out the different diameters if I want. Over here, as shown over here, or through holes or blind holes only, or both. Right now, I'm not going to do any kind of filtering of the part. Now I'm just going to click on Find Holes. When I click on Find Holes, it found every single hole that is on the part itself. And if I go into my holes tree, as shown over here, you'll note it broke it up into 4 different shapes. And we'll go into that in a moment. Plus several different groups. Now, the first shape, for example, if I were to click on this, shows me that this is a hole going through. That's the shape. And if I were to right click on shape, and I would do show hole, or you can see that there's a hole over there. Okay, if I go into group, it'll show me, since there's only one group, because I don't have any more than one of those type of holes, it shows me the actual depth and the upper level, showing me the cylinder diameter and the height of that particular hole. Now, if I were to go into, say, group shape 2, I just shown that these are holes over here. It shows me that it has the hole with a chamfer on the top. And if I go into my parameters, you can see we have the chamfer and all its dimensions. In other words, it learns everything there is to be known about that particular hole itself. Shape 3 is just a flat bottom hole, which is the one over here. And shape 4, which is a regular drilled hole with a drilled bottom over there with the different groups. Note it has different groups because we have different heights over here. We have that. We have this one, which is a different diameter as of this from this one. In other words, it knows to break each one down in each individual thing. Now, before I continue, we also have filters. For instance, let's do a hole diameter filter. In this particular case, I don't want to put a drill operation in this hole or even this one. Okay? So what I'm going to do is I can say, okay, let's do a filter on the hole diameter. I'll leave the minimum at 0, but I'll say 2. Let's pick this one over here, or this one over here. When I pick this one over here, let me put my cursor over there and then pick that hole. It shows it at 8 millimeters. If I were to pick this one, 10 millimeters. I can pick it directly off the thing. So my minimum will be 0, my max will be 10. If I click on Find Holes now, you'll note that this time it did not pick this. You'll see that you have shape 1 and 2 only 2 different shapes. So that's basically what I want to do with this operation. All I want to do is drill onto those holes itself. So let me just go back and start again from the beginning, just to show you the actual workflow. Choose a geometry, hole diameter, up to, I can even write in the value over here, 10 millimeters, and find holes. Now we have everything that I need over here. The next, I like to actually pick out a drill, and the first drill I like to pick out actually is a spot drill. So I'll choose my spot drill, in this particular case a 12 millimeter spot drill. And what I'd like to do with the spot drill is to have the tool go down up until the edge of each one of those holes, maybe even leaving a bit of a chamfer on those edges itself. Now, if I go into levels, for a regular drilling operation, I don't have to don't have to define any kind of depth. But in this particular case, since I want my spot drill to create a chamfer on each one of those edges, we have here what they call depth edit. Now, if I were to go into depth edit, okay, and just pick the first group over here. First of all, I'll go to the very bottom where it says Auto Chamfer Spot. So I have an automatic option for chamfering or spot drills. I'll click on all and I'll say Apply. So it knows now automatically to take the chamfer, the spot drill, to get down to that edge itself. Now, if I want to add a little bit of a chamfer onto that edge, all I have to do is do chamfer depth. Let's say I want to have 0.3 millimeters as a chamfer depth. I want to have it on all of these groups, and I'll say Apply. Let me just accept that and click on Save and Calculate. Before I do that, by the way, just show you that my technology field, just like any drilling operation, I'll do Save and Calculate, run my simulation, and you'll note that each hole was drilled out with a spot drill exactly according to the diameter of each hole individually and on different hole depths as of upper level, different hole upper levels. Okay, now with my next operation, I like to do drill out, let's say, these holes over here. Now, again, I'll go into recognition, drill recognition, and I'll create a geometry this time using my hole diameter filter, and I'll put it in the first field. The first field I want to have this diameter. I'll click on that diameter. Note the second field is filled out as well. So in this particular case, it will only choose the holes that are of 6 millimeters. I'll do find holes. Note it gave me different groups, and this, for example, these groups on the very top, this one and this one, even though they're the same diameter, it broke it into two groups because the depth that the hole is going to, as shown over here, these depths are different depths. They're not the exact same depth. Therefore, they're in different groups. They're the same shape, but a different group. Now, I'll just accept that. Choose a tool. In this particular case, I'm going to choose a 6 millimeter drill. And save and calculate. Now, if I were just to run my simulation, you'll see that every single one of those holes was drilled out. But not only was it drilled out, that each one was drilled out to its particular depth. Before, when I had to do an operation for these holes, I would have to do these series of holes, these sets of holes over here in 4 different operations. Now I can do that with drill recognition in one operation. Let's just continue now, and I'll do save and copy. Choose a new geometry, and again, with the hole diameter, I'll choose this edge over here, the 10 millimeter. Find the holes, and it'll give me the sets that are of 10 millimeters. Accept it. The tool will be my 10 millimeter drill. Save and calculate. Continue on. And you note how quickly I'm just working through to get to my next hole. I don't have to pick out different operations for different depths. Do it all in the same. I'm going to choose this time my hole diameter off of this hole over here, which I believe is 8 millimeters. Find holes. Note, one shape, two different groups. The group on the bottom and the group on top. The tool in this particular case is the 8mm drill. And again, save and calculate. Now I have another set of holes, these over here. So I'm going to do again save and copy. Choose a new set. And in this particular case, I can take the hole diameter being down here. I can use that one as well. Doesn't make a difference. I'll use that one over there. Find holes. I found it all. The tool in this particular case will be the 5.5mm drill. I'll select. Now note, this time I will go into my level depth edit because I want the tool, since this hole itself is a through hole, this time I like the depth to go all the way down past the edge. In other words, the full diameter to go down to the bottom. So I'll go depth edit. I'll choose full diameter on all of those drills and all those holes and apply. And of course, if I want, I can even give it a delta depth. Let's say -1mm and apply. Save and calculate. Simulate. If I run the simulation on all of these holes over here, let me just zoom in to some of the holes. You'll note that the holes have automatically left a chamfer also exactly to the diameter, and the chamfer hole is exactly to the diameter that has to go on each one of them, to the exact same depth. Okay, let me go now. Let me quickly jump over now to thread mill. In this particular part, I'd like to throw a thread mill into this surface over here, onto this diameter over here. I'd also like to do on the external diameter over here as well, and on this diameter here as well. Okay, so let's start my new operation. There we go, 2.5D thread milling. Now, picking the diameter for a thread mill, it's just like picking a diameter for any other drilling operation. I'll just click on that surface over there, and I have the center as shown over here. Now let's go to the tool. I'll create a new tool, and I'll choose the thread mill itself. Now, defining a thread mill tool can be done in two ways. One, I can use it from an existing table or from a standard table, or user define, where I can define the tool exactly the way I want to. Let's first go into tables. Now, this particular hole in here is 25mm, and the thread I'd like to put in onto it is a 25mm M25 by 1. Okay? So if I go into tables, I can have the option of choose standard, and I'll use the option of metric. Note, I'll get a table over here, a list with all different types of standard threads, whether it be thread standard or thread fine. If I go down towards the bottom and get into my fine area, I'm going to look for M25, and we have M25 over here by 1, showing us that it's a fine thread. It also shows us what our drill preparation was supposed to be, and if it's a cylinder, an external, what the external cylinder preparation was supposed to be. I'll click on OK. Note we already have in here the pitch is automatically put over here. Now the cutting diameter I can adjust exactly to where I have my tool. Let's say my tool is 16 millimeters in diameter. And then we have the number of teeth. How many teeth do I have on my tool over here in this direction? Doesn't make a difference whether it's an insert or it's a solid a carbide with the threads on it. Let's just leave it at 2 for now. For the number of teeth, 2. And I'll accept it. And we'll get back to here in a few moments. I'll select my tool. Note, it'll say automatically M25 by 1. And in my levels, I'm going to go down to that depth over there. We have the technology. And note in our technology, it automatically puts what the major thread diameter is. It took it automatically from the tool as we created from a table. Note that it's also working, we can have the option here working with compensation or without compensation. Because this is a regular milling operation. We're talking, this is a milling operation. So you can work with compensation here. Note we have the thread data, we have working internal or external. Note also the diagram on the side for internal and external. The direction, right hand or left hand. In most cases it's right hand. There are certain cases we have it as left-handed thread as well. And we have this over here cut from bottom to top or top to bottom. Now, I prefer honestly when I'm doing an internal thread to work from the bottom to top. But that's the way I like to work, for the simple reasons that I like working climb milling, and when I work on an internal thread right-handed, I have to work from the bottom up for it to do climb milling. If I were to do from the top to bottom, you'll see that it automatically changes it to conventional milling. Okay, so I'll put it from bottom to top. In this field over here, we have our rough. If I want to do a rough cut first, let's have a rough cut first and leave 0.05, 5/100ths of a millimeter to be finished off. And we also have our finish. Let's just do a quick save and calculate and see what we have up until as far as simulation. Now I'll do this using the host CAD simulation. Note in this case, the tool will go down. And if we look for the top, first of all, you can see that it goes directly in the center, moves to the side, and then works in an arc into the radius itself. Let's just turn it to the side, and you can see that happening as well. You have the tool going down, and then start slowly but doing a helical motion up until it gets to the very top, having one entrance and one exit of the tool. Also note that we have here the rough cut and the finish cut. Okay, now let me go back to the tool itself. And we have an option here of clear offset. If I don't want to go into the wall itself and directly to 0.05 millimeters before the end, and I want to do this by step, I have the option of clear offset. Let's give it a clear offset of 0.4 millimeters, and a step over would be every 0.1 millimeters, 1/10 of a millimeter every single time. In other words, it will work its way from the outside at 0.4 and then working its way in to 0.1. Let's do save and calculate and simulate again, looking from the top view. And I'll zoom into this area now. You'll see that we have it stepping in every 0.1 millimeters as it goes around. And at the very end, it leaves 0.05 and then finishes off the part. Okay. Now, let me make a little change in the tool. I'm going to go back to the tool, and I'm going to say, okay, you know what? This particular tool doesn't have 2 teeth, it has 4 teeth. So I'll put in the amount of teeth as being 4. I'll do select, save and calculate, run my simulation. Let's zoom into this area over here. And note what happens this time. Instead of doing one continuous motion from the top to the bottom, since the tool can cover 4 threads in one shot, so it does one turn, it did 4 threads by doing that one turn, it'll go back to the center, move its way up, and then go back in, do the next turn. In other words, you'll be saving the amount of spirals that the actual tool has to do. Okay, now let's go into my next operation. This time, I'd like to work on the external of this particular area of this particular diameter over here. So I'll do, again, 2.5D thread milling. I can even use, in this particular case, the exact same geometry. Show that point exactly in the middle. Now let me go into my tool, and I actually want to create this time a new tool. Again, thread milling. Now let me go into my standard for a second, and this particular case, the diameter over there is 35 millimeters. I also want to have this at 35 by 1. Now if I could go down in my list, you'll note when I get to M35, there is no standard of M35 by 1. It's only M35 by 1.5. So in other words, this must be, in that case, a special thread. So let's close this. And instead of using the table, I can use user define. Now in user define, I'll just put in the values that I need over here. For example, my pitch. I'm going to have my pitch at 1 millimeter, exactly the way it is right now. The cutting diameter, I'll have that at 16. All of this information can be put into here exactly the way it is. And of course, number of teeth. Let's put this also at 4 teeth. And I'll do select, click on select. The levels, my depth will be up until that surface over there. And in my technology, since I created this operation manually, you'll note that when we have internal, external, the value that's over here is 0. In other words, I have to put in the value. So I'm going to use external. I'll put in the value right now is 35 millimeters. And again, just before I have the option of right hand, left hand, bottom to top. This time I work top to bottom because I still want to work climb milling. So I work top to bottom and again do save and calculate. One more thing. When I'm working from external, as I'm doing now, if I go into my link, I can actually put in the value of what I want my arc to go in at. Let's say I'll have it at 5 millimeters. Take a look at the top over here. You'll note it did the radius from the outside and worked its way up. Did the radius, and you can see as I zoom in over here, worked its way up, and it did that one radius, worked its way out, then went up the next step. Now, what I'd like to do again with the same tool is this diameter over here. Now this, in this particular case, this is a very large diameter. If I were to touch the edge over here, you'll see, here we go. Touch the edge, you'll see that it's a diameter of 150 millimeters. If I were to, I have my same tool, my levels, in this particular case, my upper level is over here, and my depth is up until this floor over here. If I want to go down, delta depth, say minus 0.5, half a millimeter past. In my technology, I'll leave everything exactly the way it is. If I want to do a rough cut, not a problem. I'm working internal, and this time over here I put down 150 millimeters. Okay, let's do save and calculate and run my simulation looking from the top view. And you'll note the tool, again, goes down exactly. Oops, sorry, I forgot to pick my geometry. My mistake. Let me go pick a new geometry on that hole over there. Save and calculate and simulate. Now note, now show the tool even. When it goes in, what actually happens? It goes in directly in the middle. Then it goes to the side and then works its way around the part itself. Everything is really nice. The problem with this is that since this is a very large hole, 150 millimeters, when it goes to the center over here, it takes a while to get, in other words, it goes according to G1 to this area over here and then going on. In other words, there's a lot of wasted time over here. And what I'd like to do is actually shorten this to over here to work directly onto this arc over here. What I can do in this particular case, since I'm working external, if I go into the link, I can say start from center, which is what it's doing now. Sorry, when I'm working internal, I'll say you have either start from center or without start from center. If I remove that from there now and run my simulation, you'll note that my tool this time from this area over here, again, coming in and working in this area. You're saving that time from going from the middle into the part itself. That's how you can create this one, and that's how you can do it also by saving time from going off to the edge. Now, that's basically what I wanted to show you, these two operations. But before I go on to questions, there's one more thing I'd like to show you. If I were to show you right now my Solid Verify simulation, okay, and I'll go from the very beginning, from the first operation. I said Solid Verify. My mistake. Solid Verify. Okay, you have your, let's just go past this point over here. Putting in the steps. We have the drills. Now we have the thread being done over here. Same thing here until the very end. Now, you'll note, however, that when I look at these edges, Solid Verify actually just takes a regular tool. It does not know how to make a thread mill. And I actually want to see the actual threads on this part here in the simulation as well. So what I can do is a little trick I've learned. If I go into tools, just a moment, I'll go into my tool table over here. And I'll pick the tool of number 13 and 14. If I have to go to drill, say 13, I can go into shape and I can create, actually, and I've done this already, I've created a shape tool. If I look at the shape itself and I'll zoom into it, you'll note that it has, I created a shape tool that has the exact same pitch on the tool itself and the exact same amount of teeth, 4 teeth. Also, it's important to note that the diameter, the outside diameter over here should be the same as the tool. In this particular case, it is 16 millimeters. Now, let me do the same for my next tool over here as well. Go into shape. Choose that exact same tool. Now let's take a look at the simulation. First, let me do calculate of this operation here. And now I'd like to do the simulation of these 3 operations using Solid Verify. If I were to run the simulation now, let it go to the very end. Now, let me zoom in. Sorry, didn't do that. T13 and T14. Sorry, T14, my mistake. Didn't put the right thread, didn't put the right, didn't make it a shape tool. There we go. Okay. Let me just recalculate those two operations. Calculate, run the simulation on these three operations over here, simulate. I'm going to zoom in a moment on these operations over here, and soon you'll be actually able to see the actual thread on the part itself. By using a shape tool, I can actually do that. Okay, if I take a look now, you can see the actual threading on the part itself. You can even see where the thread started over here. Or in this particular case, since it went down from the top to the bottom, where it finished, without obviously hitting the bottom of the surface over here. Same thing in the inside. Again, exactly the way the thread had to be done, as well as this surface over here. So all of the threads were done, and you can see by using a shape tool at this point, I can actually see the thread during simulation. Okay, I'm going to go through the questions that we have here now. Okay, does drill recognition work on multiple MAC positions? Yes, it does. I can, but remember, it's a one drill operation. It's a one tool operation. I have to do this operation in each MAC. In other words, I can't do this. I can't do this on one and just recognize all the MACs in one shot. I have to do it on each MAC itself, on each MAC position. Okay, does drill recognition work with multiple diameters? It recognizes, but remember, again, this is a one tool operation. Okay, this is not what we call hole recognition, where it gives you a whole series of different operations just by seeing the hole. This particular option of drill recognition is a one tool operation. So yes, it'll recognize it, but it'll only use one tool. And if I want to go down with another tool, I'll just do save and copy of that operation and then put in a different tool itself and bring it to the height that I need to bring it up to. Good question I see over here. How does drill recognition cope with holes entering a face not perpendicular to the drill? First of all, remember, if it's on that MAC position, it's a regular drilling operation. Just remember, just picture any drilling operation, and you have to have the drill, if you have to have a MAC with the Z is perpendicular to that hole. So if I were to have a hole on this surface over here that's on an angle, that wouldn't be in MAC 1 anymore, or position 1 anymore. It would be a different position altogether. The webinars, these recordings will be put, by the way, these particular webinars we are going to be building now another section in our website for all the lesson webinars that I'm giving to right now. All these Wednesday webinars will be put now on the website itself. As far as if you have it as a question here, as far as if you have a canned cycle for thread milling, then this is not the operation to use. In that particular case, and you would probably have it already in your post processor as well, where you just use a regular drilling operation, and one of the options as far as the drill itself goes would be thread mill. And there you would have it, that will be inside your regular drilling operation. This is an actual milling operation, okay, but using the center hole, using the geometry of a hole. However, as far as canned operations itself goes, that will be put and can be done inside your regular drilling operation, adding an option of thread mill, and that's with your post processor itself. And you can deal with, you can ask your dealer, actually, whoever your reseller or your SolidCAM support unit, to actually help you out with that if you don't have that yet. Okay. Thank you everyone for joining the webinar. This webinar has been recorded itself also as well. And as I said, we will be creating very shortly, within the next day or two, we'll be creating a section on our website that will have all the SolidCAM customer webinars, that you'll always be able to look at them as well. There's one more question I see. As far as the last question, in thread milling operation uses a drilling cycle. True, and you will not see the, doesn't show the tool movements. That is one of the, in the drilling cycle, you do not see the movements over there. That is true. That's nothing, that is something that, because it in itself is a drilling operation. So it'll just go up and down as far as the simulation goes. What it'll actually do on the machine is, it will actually show you the, it'll actually do the proper thing. It will actually give you the right type of operation there. However, if you have a simulation, a G-code simulator, if you have a G-code simulator available, then in that particular simulation, it'll show you the actual movements when it works off a G-code simulator. Okay, again, thank you very much for joining us. Everyone have a great weekend, and in another 2 weeks we'll be having another webinar. Take care and have a nice day.